Today we are going to try to solve the count primes problem, which is an easy math problem which, according to Leetcode, is frequently mentioned or used at job interviews. So the task is, given an integer n, we need to return number of prime numbers that are strictly less than n. There are several ways to approach this. And what we probably could start with is to calculate what is best conceivable result for the complexity and space complexity and time complexity. So we have n numbers. So I think that the best conceivable result will be O(n), and best space would be O1. Now, that's a best conceivable. So it doesn't necessarily mean we will be able to achieve that. But that's something that where we can start. And then using these numbers, we should be able to understand if we need to improve our solution or not. I usually suggest starting with a simple and brute force solution. So in my case, I believe what we should start with would be generating a sequence from 0 to n. That's pretty simple in Python. So for e in range n, essentially that's gonna generate us a sequence from 0 to n. And then we going to validate if a particular number is prime. Now we need somewhere to calculate the result. So let's say result 0, then if is prime e, and then we increase the result, return result. Done. So let's run the code. What is very good about Leetcode is that we can use a custom test case. So obviously our code is not going to pass for 10 because there is no isPrime function, so it's not going to pass anyway. Sorry for that. Let's add this isPrime. It takes number and returns false for that, right? So, okay. For 10, it's going to return nothing, but there are two values where we should return a decent result. So I believe for n equals 0, we return a correct result already. Yeah, expected 0, our answer 0. And for the word 1, it also should be 0. Now 1 is a prime number, but the reason why we return 0 is because we are looking for prime numbers which are strictly less than 1. And there is no such prime numbers. The 1 is the first prime number. Now what we can do. So what is prime number? Prime number is a number which is divisible only by 1 and by the number itself. So what we can do now, we can start with something simple. Let's say if number equals 1, return true. And that's going to help us to pass one more test. Oh, that's not true. 2 will be the first prime number here. Okay, let me see. Yeah, okay, so 2 is the first prime number. That's interesting. I actually thought that 1 will be also a prime number, but well, nevertheless. Okie dokie. So what we've got here, we have a best case. So the brute force solution for this would be to try to divide this number that we're given by anything except this number itself. So for example, we're here going to say result equals false for e in range 1, that number. We start with, or actually it's not 1, 2, because everything is divisible by 1. if, oh, we don't need a result here, we can just get rid of it. So if number is divisible by e equals 0, we return false. It is not a prime number. If it is not divisible by e, we return true. Now, this looks like a complete solution to me, but let's test this. So let's provide 10 and see if we get a correct result. So for 10, we have 2 as a prime number, 3 as a prime number, 5 as a prime number, and 7 as a prime number. So we should get 4. Clearly, something is not right. We got 6. Let's see what's going on here. One way to see what's going wrong is to add print statements. And I think that the error might be here. So I would like to see if I use range correctly. So E and number and E, and see how it performs for, let's say, 5. On 5, we see there is already an error. So that shows something. Okay, so 2. So I want to add some print here as well. So let me add this print e result. So for 5, let's see how it goes. So for 0, we get result 1. For 1, we get result 2. Hold on a second. That's not right. Okay. That's because we have a problem here. The bug is we should have checked for 1 and 0, because for 1 and 0 we should return false. So let me do if number equals 1, according to the logic here, it should return false. So that was the first error, I believe. So let me run code. Okay, now that's not yet better, but we improved a bit. So for 1, we did not increase. I believe the thing is here for 0. Yes, that's because we are starting from 1 here. Okay, one way to avoid this kind of problem is to start iterating from 2, and we will not need to change if here, which is not necessarily the good thing to do, because if I want this is prime to be universal, I should not assume that the input for this is prime is a special. And what I'm doing now, I'm making a special input. So even though I still think it is a good idea to count from 2 here, because we don't need to check if 0 and 1 are prime, we know they are not. But I will still going to change this is prime because I want this to be universal. Now, this is not important for this particular task, but for example, for an interview, that may be important. So if number equals 0 or number equals 1, return false. Lovely. Now let's run code, and now we should solve the problem. Okay, yes, we did that. So it's gonna pass for 10 as well. Yes, so it is now seems to be functionally correct. We have, I believe, O1 space complexity because we don't create any kind of unnecessary list or race. However, we have ON space ON in the power 2 space time complexity. Sorry. All right. So this actually may fail due to timeout. Let's see if Leetcode will be happy to accept this solution. Based on the fact that it is thinking for too long, I think it's going to time out. Yeah, that's Oh, that's output. Okay, that's one of the things on the Leetcode. If you produce too much output, it can fail simply because you just produce too much things. Let's see. Yeah, now we have this problem with the time limit exceeded. The reason for that is that we have this huge number. And for this huge number, we need to make lots and lots of different calculations. So now what we need to do, we need to find some smart way to check in if the number is prime. One of the first things that we can do, we can notice that we do unnecessary calculations here. So here, in fact, we don't need to check up until number itself. Instead, we can use a first integer to the square root of number. Let's see, square root, that should do it. And that's going to make our code faster. Let's first check on a short input if I did not break anything. Yeah, I certainly did break something. Let me see what it could be. That's because when we do this, we are not including the square root of number because of the way range works. And we may want avoiding this. So now it should run better. A int number. Oh yes, that's because I have forgotten this. All right. Yeah, my answer is now correct. Let me see if it is still not passing timeout. But before that, let us calculate what is the space and time complexity for this problem. Regarding the space complexity, nothing changed. Regarding the time complexity, we actually improved a lot because now we have ON in square root of n, which is significantly lower than what we had before. Right, let us try to submit the code and see if it's going to pass through the timeout. I'm assuming that it's not, because I believe what they want us to do is to somehow come up with ON log n or ON solution.
It turns out there is actually a very smart way to solve this problem. You can Google the algorithm on the Wikipedia, but I will try to briefly explain this. So let's assume we need to count prime numbers up to 10 as an example. What we can do, instead of going through all the numbers from 0 to 10, we can try to generate literally numbers which are not prime. So what we can do, we can start with 2 and try to add 2 for this until we get a number which is less than 10. So essentially we're going to have 4, then we're going to have 2 plus 2 plus 2, which is 6, and then 2 plus 2 plus 2, which is 8. We don't count 10 because we are not interested in 10. So we know that there are at least 3 non-prime numbers. Then we go to the next number, which is 3. And we do the same. We check 3 plus 3, there is 6. So we know 6 is here already, so we kind of just ignore this. And we do 3 plus 3 plus 3 equals 9. That's a new non-prime number, so we calculate this. Now we know that there are at least 4 non-prime numbers.
Okay, so what we're going to do here is first we're going from E equals to 2 square root of n plus 1, because we want to include square root in the sequence. And now what we're going to do, we're going to generate all non-prime numbers. Okay, so let's say non-prime numbers, which is a dictionary of non-prime number. And what we're going to do here, we're going to add a nested loop. So for e in range 2e. So why 2e? Because that's the first product of the number that we are going to calculate. So 2e until n with a step e. Okay, that should have a different name. That's g. Or g, then g, and what we're going to do, because we know that every number here is not prime, we are going to add them here. So non-prime numbers, g equals 1. All right, so what we're going to get here is what we now can do. The result will be n, the total number of numbers, minus 2, 1 for 1 and 1 for the n itself, and minus len non-prime numbers. Okay, now that should do. Let's start from a small test first. Okay, yeah, it's not working because for g in range to g. Okay, because that's was supposed to be 2e running code. And we step again e. That was supposed to be e. Now, okay, the result is correct. Let's try some big input and run code. You see, we are pretty fast now. I feel good that we should be able to pass the requirements for the time. So wish me luck. All right. Okay, so that's a very humiliating problem. So you see, the input here is 2. The input here is 0. And we return -2. Well, obviously, to avoid this, what we need to do is to add another if here. So if n smaller than 2, we just return, well, actually smaller or equal to, we just return 0. And that should work. But the good news here is that it was just a wrong answer, not a timeout. I really want to be able to get through this timeout. Oh, no. Okay, that's something extremely big. The fun thing that we are nearly there. That's interesting. So when I'm trying to submit, the timeout is exceeded. When I'm using this test case here, it's not. Maybe something wrong is going on here. So let's use 5 millions. That was the one which timeouted. Yeah, it is working fine now. So I don't really know why the timeout is jumping in. I believe there is some kind of issue on Leetcode itself. It has nothing to do with my code. But this was a very interesting task. Oh, hold on a second. Okay, it has actually passed with the same code, with no changes. Yeah, that definitely was a problem with Leetcode. Well, that was a fun challenge. I thought I will spend just 20 minutes on it, and I spent, like, I don't know, almost an hour, maybe more. But I hope you find this useful, and I hope you like the format. So if you do, please do like this post and video. Please comment with your suggestions, because I ultimately try to make good videos for you. So your feedback is really appreciated. That's all for now. See you soon in new videos.